Welcome to my KCSE revision channel. Marita James. Kindly subscribe, click the notification bell, you get notified once I upload a new video. Today we are looking at Form 4 work, energy changes in chemical processes. We are looking at the heat of formation. Most students, candidates, they leave this question blank in the Kenya National Examination. Some who attempt, they do not get it correct. Calculate the enthalpy of formation of hydrogen chloride, given that hydrogen gas reacting with chlorine gas, it is forming the hydrogen chloride. The bond energy between hydrogen is positive 436 kilojoules per mole. Chlorine and hydrogen, positive 431 kilojoules per mole. Chlorine and chlorine is positive 242 kilojoules per mole. This information is normally provided in an examination paper. Now in this question, you need to know that there is a bond breaking and there is a bond formation. So first of all, you need to calculate the bond breaking. Bond breaking is between the reactants and the bond formation is on the product. So bond formation, we first of all we can find the bond breaking. So we have bond breaking. We can calculate bond breaking, and the bond breaking, you need to understand that it is always an exothermic reaction, therefore the value is positive. Understand this one, that this is an exothermic, it is an exothermic reaction. So let us first of all find the bond breaking. So in bond breaking, and this one is involving the reactants. So we have, in bond breaking, we have hydrogen. This one is giving us, so we have two molecules of hydrogen, so you can have two hydrogen, and this one is the atomization of hydrogen. This is atomization. It is an atomization of hydrogen. This is atomization of hydrogen. So what do we have? From the value here, we have the bond. We have one bond which is equivalent to positive 436, but we have two molecules here. So this one is equivalent to, you can have this one as molecules of hydrogen. So we have these two here. So this one is giving us, we have this one as positive 436, in this case kilojoule per mole. Then we have chlorine molecules. So we have chlorine, we can have a bond between chlorine. So this one is also giving us chlorine. So these two, it is this one here, and these two, it is that. And this one is the atomization of, we have this one as atomization of chlorine. This one has atomization of chlorine, which is giving us positive 200 from here, and 42, in this case, kilojoules per mole. So the total energy, now you calculate the total energy. Total energy for atomization. Total energy for atomization, we have positive 436 kilojoule per mole, then plus, into bracket also we have positive 242. This is kilojoule per moles. So if you can have calculate this one as 436 plus 242. So we have this one as positive 678. So this one is giving us positive 678. In this case, kilojoules per mole. So this is the bond breaking. It is always positive, and therefore you have to indicate positive here to show that the reaction is an exothermic. Then from here, we need to find the bond formation. So you will have bond formation. The bond formation is always an endothermic reaction, and therefore the value is negative. This one is endothermic. That one is an endothermic reaction. That one is an endothermic reaction. Therefore, we have bond breaking is an exothermic, which is involving the reactant, and the bond formation is an endothermic, and this one is involving on the product. So what do we have on the product? On the product we have hydrogen chloride. So we have the hydrogen chloride. Hydrogen chloride, it is hydrogen bonding with the chlorine. So we have only one bond here, but from the reaction we have 2 moles of this one, of 2 moles of 2 moles of hydrogen chloride. So first of all, we can have this one, and this one is the bond formation. So this is the bond formation of this one. The value is equivalent to, we have as a negative 436, negative 431, in this case kilojoule per mole. Why a negative? It is a negative to indicate that the reaction is an endothermic reaction. So we cannot find now the total energy. We find the total energy. We have total energy of formation. Total energy of formation of HCl will be now equivalent to, this one is equivalent to P, negative 431 times 2, because from our reaction here we have these 2 molecules of hydrogen chloride. So if you have this one as a negative 431 times 2 from our calculator, negative 431 times 2 is giving us negative 862, in this case kilojoule per mole. Now you need to understand that the enthalpy of formation now, the enthalpy of formation of HCl, this one is equivalent to P. It is bond breaking, the value of bond breaking, plus the value of bond formation. So we have this one as bond formation. That is the formula. So this one will be equivalent to P. Our bond breaking is positive, so we have this one as positive 678, and then plus into bracket minus 862. Remember, this one must be an endothermic reaction, and therefore it must be a negative. So this one will be equivalent to, we can have 678, you will subtract 862, and this one is giving us negative 184. So this one is equals to be negative 184 kilojoule. Now, this is not the answer. We need the enthalpy of formation of HCl, 1 mole of HCl. So from here, this one is 2. So 2 moles of HCl is producing negative 184 kilojoules per mole. So 1 mole of this molar enthalpy of formation. So you need to have the molar enthalpy of formation. Mole enthalpy of formation of HCl is now equivalent to this one. You can get as negative 184 kilojoules. You divide by, we are dividing this one by 2, such that we have 1 mole. So this one we divide by 2, we are getting this one as negative, and the answer, final answer is negative 92 kilojoule per mole. Kilojoule per mole. In most cases, in a KCSE setting, most students, they leave these questions blank. In fact, 80% they do not do this question. The 20% who attempt this question, they do not get it correct. So this is how it is supposed to be done. Follow my channel, click the notification bell, you subscribe, you get notified once I upload a new video. You will get more of these calculations.